4, 3, 2, 1, wrestle. Or not. Come on. There we go. Okay, I call your attention to the important 1%. Why don't you try explaining your point of view to whoever sits near you? There does not appear to be any kind of unanimity here. Which one?
I think B. If you move the axis way over here,
Uh-huh. So discuss.
I see how it is.
No, you're not. So
What did you
have
pick?
things here.
Only if the axis is fixed.
So I mean, it'll be like a really thin.
What did you pick?
I picked A originally.
Oh, but you may be moving to a different answer? Okay. Which did you pick? D? I'm going to try. Okay, vote again. Wait. 5, 4, 3, yes please, 2, 5, 4, 3, and the number of the counting shall be done. Okay. Oh, didn't we have B before?
I think we had A before.
We had A before? We had all of them, but now...
We've got more E.
Okay, so that's still 1%. But we have a lot more saying D. Is there a spokesperson for D? He said, playing obscene favorites. Yes?
So one really good explanation we saw was that they must, doesn't matter where the center of mass is, you must all be moving at the same angular velocity as your body is coming apart. Because by definition, wherever you put it, they're covering the same data.
Here's an object.
Don't hit me.
Oh no, I used chocolate for that, Jessica.
Oh, hit me.
Okay, so here's an object, and if I rotate it like that, everybody on the object rotated around the same. Okay, now let me rotate it about its center of mass. Now let me rotate it not about its center of mass. Did every part rotate the same 90 degrees? Pretty much. Okay? There's a theorem which has struck me as kind of like the derp theorem, just sort of like, it's not obvious. But the theorem is that for a rigid body, you can express its motion always as, from one position and configuration to another, as the combination of a translation of the center of mass combined with some kind of crazy rotation about the center of mass. And that's sufficient to put the body in any configuration. So the answer here is, say it loud and proud, please. D, yes. It's always, unless the body, as Jessica points out before chocolate, falls apart. Okay, so if it's rearranging itself, then it is no longer true.